review what we discussed, and we can continue from there. So while this loads, like we said, every plane has two different parts to it: a normal vector and a point on the plane, a point that the plane contains. And then if you want to talk about that plane, you can talk about the plane with that normal vector at that point. And so okay. So what we're looking for, again, if you have a plane and we have a normal vector to the plane, so here's our normal vector. It's orthogonal to the plane, which means that for any vector in the plane, so for any vector v in the plane, we have that n dotted with v is equal to 0. So what does this tell us? This tells us that n dotted with the vector. So the vector v, if I write this again, the point over here, if we write this point as the point x0, y0, z0, so that's one point on the plane. And then for any other point on the plane, because we're looking at the set of all points on the plane, we can just write them as x, y, z. Then this equation becomes n dotted with x minus x0, right? So the vector from x0, y0, z0 to x, y, z, it's going to be x minus x0, y minus y0, and z minus z0. And so now, if my vector n, if I say that, okay, let's imagine my vector n is equal to a, b, c, then this thing becomes a, b, c dotted with x minus x0, y minus y0, z minus z0. Oh, sorry, this is equal to 0. Is equal to 0. And so then this gives me a x minus x0 plus b y minus y0 plus c z minus z0 is equal to 0. And then this gives me ax plus by plus cz is equal to a x0 plus b y0 plus c z0. And so the form of every plane has the form ax plus by plus cz is equal to d, where the a, b, and c are the normal vector. They form our normal vector. And the d, well, the d really is equal to ax0, by0, cz0. Or any point on the plane, you can just plug it in for x, y, and z, and that will give you your d. Any questions about this? So we did an example, I think last time, so I'm gonna do another example now. So let's imagine that they ask us to find a plane with a normal vector equal to 1, 0, 3, and a point P0 equal to 2, 1, 1. So my plane will have the form x plus 0y plus 3z is equal to d. And now I want to find the number d. So the way I do that is by taking this point and plugging it in for x and z. So that gives me 2 plus 3z, which is 1. So plus 1 is equal to d, which over here is going to give me 5 is equal to d. So now my d is equal to 5. So now I know that the plane is going to be the plane x plus 3z is equal to 5. And again, the question is, does it satisfy the conditions that they gave us? So does it have a normal vector 1, 0, 3? Yeah, that for sure, by construction. And does it contain the point 2, 1, 1? Well, yeah, if you plug in a 2 here and a 1 here, you get 5. So check. And this point is contained in this plane, and this is the normal vector, so this is the correct plane. Any questions about that? Okay, so let's go over what they have over here. So this is doing what we just did. We have the normal vector here dotted with x minus x0, y minus y0, z minus z0 is equal to 0. You put in the a, b, and the c. You put the ax0 plus by0 plus cz0 on this side, and you get that your plane is equal to that. And so then your d is equal to ax0 plus by0 plus z0. So we now know how your plane looks and what d is going to be. So in vector form, your plane looks in the form of n, your normal vector, dotted with x, y, z is equal to d, is equal to ax0 plus by0 plus cz0. And in scalar form, your plane looks like this, or like this. More importantly, it looks like something like this, where your d is equal to that. So if you want to ever find your plane, we know exactly how it should look, and we know exactly what we need to do in order to find our d. So they now ask us to find the plane with the normal vector 0, 0, 3, and the point p0 is going to be 1, 2, 0. So if we have a normal vector 0, 0, 3, we know that our plane will have the form 0x plus 0y plus 3z is equal to d. And now it needs to satisfy this equation over here. So we can plug in to this, we can plug in this point, and we get 3 times 0 is equal to d, which is equal to 0, which tells us that d is equal to 0. So our plane is going to be of the form 3z is equal to 0. And that's the plane. And it's yeah, okay, so this is the point, this is the normal vector, it's pointing in the z direction, and the plane is going to be that plane right there. Any questions about this? So it's also the plane z is equal to 0, same thing, which is the xz plane. So it's the plane lying in the x, it's the xz plane basically. It's the plane where z is equal to 0. So when is z equal to 0? Down here where, the z direction gets squished. Okay, is this clear?
Yes.
Yeah, okay. So now what they want us to do is they want us to find the equation of the plane through the point. Okay, so yeah, basically what we've been doing until now, same exact problem. So again, when we have a normal vector, we can write out the way our plane looks. So it's going to be 3x plus 2y minus 5z is equal to d. And now we have this point P0 over here. So that's going to be 3 times 3 plus 2 times 1 minus 0 is equal to d. So in other words, d is equal to 11. So that tells us that the equation of our plane is 3x plus 2y plus 2y minus 5z is equal to 11. So 3x plus 2y minus 5z is equal to 11. Perfect. Okay. So another thing, like we said before, if you have different planes, you can have many different planes that are parallel to each other. So if this is your x, y, and z coordinate, you can have one plane over here, and then you can have another plane, and we can have that they're both parallel to each other, which means that they both would have the same normal vector, same exact normal vector. This would be the normal vector n, and this would also be the vector n, or some multiple of n, or something like that. And that's how we can say that these two planes are going to be parallel. The only difference between them is their P0. So they're going to have different points, a different point that was chosen. So, which is x0, y0, z0, which is used to find your d. So the d is going to be different for the two different planes. So the two different planes will look something like ax plus by plus cz is equal to d, where my normal vector is equal to a, b, and c, and my d is going to be a little different. So they're asking us to find the, okay, let P have the equation m7x minus 4y plus 2z is equal to -10. Find an equation of the plane parallel to P passing either through the origin and then through the point Q. So let's try the origin. So if you want the origin, you have to look at 7, 0 minus 4, 0 plus 2, 0. So that's plugging in the origin, and that's equal to 0. So your d is going to be equal to 0. So then your equation over here will have the same form, but just a 0 over there. So it's going to be 7x minus 4y plus 2z. 2z is equal to 0. For question B, it's going to be very similar. Again, you just plug it in. So you're going to get 7 times 2 minus 4 times -1. So this is going to be plus. And then plus 2 times 3. And then this is going to be equal to, and I'm going to cheat and just look here, 24. So this is equal to your d. So now your equation is going to have the form 7x minus 4y plus 2z is equal to 24. Okay. So another thing that we would like to be able to do that comes up quite often in quizzes, tests, homeworks, and stuff like that is if we have 3 different points. So again, this is x, y, and z. Let's say I give you 3 points, 1, 2, 3, and I ask you to find the plane that goes, so here are the points, and I want you to find the plane that contains these 3 points. So how can we do that? And the solution is fairly simple. You call this point P. So here's the point P, here's the point Q, and here's the point R. And then we first find the vector PQ. So that's the vector going from P to Q. That's this vector. Then we can find the vector PR. So that's the vector going from P to R. And now in order to find this plane, we need to find its normal vector. So we need to find a vector orthogonal both to PQ and to PR. Some vector like this. And that's going to be the vector PQ cross PR. That's going to be our normal vector. And once we find our normal vector, we can finish the problem fairly quickly by just taking our P and using it for P0. So then just take P is equal to P0. So I'm going to do an example of this right now, but is the overall strategy clear? Is it clear what we're trying to do and what the overall strategy is going to be?
Yes.
Wait. So let's take our 3 points to be, so let's take P is equal to 1, 0, 1. Q is equal to 2, 2, 1. And R is equal to, let's say, 0 to -2. Okay. So now PQ, which is Q minus P, is going to be 2 minus 1, so that's 1, and 2 minus 0, so that's 0, and 1 minus 1, so that's 0. And then PR is going to be R minus P, so it's 0 minus 1, which is -1, and 2 minus 0, which is 2, and -2 minus 1, which is -3. So these are the two vectors. So far, what we've done, so we have our 3 points, P, Q, and R. And so far, we've found this vector and we found this vector. And now we want to take the cross product. And this is going to be the PQ cross PR. So that's what we want to do now. We want to take the cross product of these two vectors. So let me erase this. So what is PQ cross PR? Well, that's equal to IJK of, and then you have 1, 2, 0, -1, 2, -3. So this is going to be equal to I, and then you're going to have 2 minus 3, so that's -6. -6. 1 second. Yeah, and then -0. So, okay. Minus J. So now for J, we're going to have -3. And then -0. So that once again, so I'm just going to put a plus here. Okay. And then for K, so plus K. And then we're going to have 2. 1 second. Okay. 2 and -2, so +2. Okay, so this is going to be the vector -6, 3, and 4. Okay, so here's my normal vector. Sorry, can anyone read out the points? What's the point P again?
1, 0, 1.
1, 0, 1. Okay, Q.
2, 2, 1.
2, 2, 1, and R.
0, 2, -2.
Okay, thanks. Okay, so now our plane is going to be of the form -6x plus 3y plus 4z is equal to d. And now let's plug in P, over here in order to figure out what D is. So that's going to give us, second, that's going to give us -6 times 1, and then the y is 0, and then plus 4 is equal to D. Or in other words, D is equal to -2. So D over here is equal to -2. Okay. And let's make sure that this works. So we can also plug in the point Q or the point R. Actually, yeah, this would not work for R because you would plug in a 2 for here and a 2 for that one. So there might have been a mistake somewhere. So let's see. So in the cross product, we had I, and then for J, we had -3, so that looks right. And then the K is going to be 2. So I think the cross product looks correct. 0 minus 1, 2 minus that, 2 minus that, okay.
For the z value in P, it should have been -1 instead of 1.
Oh, here? Like that?
Yes.
Okay. Okay, so then this is going to be -4 is equal to D.
I'm pretty sure all of those points with if that was 1, 0, 1, I'm pretty sure they all equal -2. Because you plug in 3 times 2 is 6, and then 4 times -2 for R, because you said R was incorrect. If you plug in 3 times
Right, no,
2
but I'm saying
negative.
R is 2 and -2. So if you plug in 2 here, oh,
Yeah, that was correct what you had originally. Because the original point is 1, 0, 1, not 1, 0, -1.
okay, fine. Okay, sorry. Yeah, I just was not, I didn't do the arithmetic correctly. Okay, fine, I apologize. So let's do this one again. So you plug it in, you get -2, right? So we got that D is equal to -2. And then, yeah, if you plug this in, so you get 2 over here, so you're going to get 6. And then plus -2 times 4, which is -8, so that's -2. And then if you look at Q over here and you plug this in, so you're going to get -12, and then you're going to get +6 and +4. Yeah, which is also -2. So good. So this works. Okay. Any questions about this? Okay, so again, the overall strategy, if we have 3 points, is create the vectors between the points, take the cross product. That's going to give you your normal vector. You put it into the equation for your plane. You then find your D by choosing one of these points and plugging it in. And then you can verify that your plane contains the 3 points by plugging them in and seeing what happens. Okay, so here they give us another question, 3 points, so let's do it. So again, we want to find the point, the vector PQ. So the vector PQ is going to be Q minus P, so it's going to be 2 minus 1, and then 2 minus 0. And then 1 minus minus, so that's 2. Sorry, 2 minus 1 is 1. And then the vector PR, and this is going to be the vector R minus P, so it's going to be 3, 1, and 2 minus, so like maybe 3, yeah. Okay, so these are our 2 vectors that go from the point P to the point Q and from the point P to the point R. So now we want to find our cross product. So we want to find PQ cross PR. So that's going to be equal to I, J, K. And then we're going to have 1, 2, 2, and 3, 1, 3. And now this is going to be equal to I times, and then you're going to have 2 times 3, which is 6, minus 2, minus J, times 3, minus 6, plus K, times 1, minus 6. Okay, so now this is equal to the vector 4 over here, and then this over here is going to be a -3, a negative is going to give us 3, and this over here is going to be 5. And this is our normal vector. So our normal vector is the vector 4, 3, 5. Okay, so now when we make our plane, so the equation of the plane will be 4x plus 3y plus 5z is equal to d. And now let's choose the point P to go in here. So this is going to be the 4
Negative
plus
5.
-5, yeah. Oh, yeah. Sorry, this is negative because yeah, this is negative, so this is negative. Thank you. Okay, so 4 and then plus 0 and then minus and then -1, so plus 5. And then this is equal to 9, which is equal to d. So d is equal to 9. So that tells me that the equation of the plane is going to be 4x plus 3y minus 5z is equal to 9. Okay? So when they do this over here, that's basically the same thing as just plugging it in. The dot product of the normal vector with the point, that's exactly the same thing as just doing this, just plugging it in. Yeah, and this again is the cross product, finding the two vectors. Yeah, any questions about this? Okay. So another thing that they would like us to be able to do is finding where a line and a plane intersect. So if you have an equation of a plane, so the equation of the plane is ax plus by plus cz is equal to d. And now you have a line, r of t is equal to r0 plus tv. So they want us to be able to tell where this line and this plane intersect. And the way to do this is by rewriting this line. So we know r of t. So yeah, we know that this is equal to r0 plus tv. But we also know that that's equal to x of t, y of t, and z of t. Okay, 1 second. Okay, and now we can take these and we can plug it into this equation. So a of x of t plus b of y of t plus c of z of t. And we see where this is equal to d. We're going to find the t where this is equal to d, and that will tell us where the plane and the line intersect. And in geometrically, what we're doing, and this might become clearer if it's not clear already when we do a problem, but we have a plane. So here's our plane, and we have a line. So here's a line. And we want to know where they intersect. So this line is parameterized by t. So here's t0, t1. And we want to find the t where the line and the plane intersect. Okay, so let's see. They're going to give us a problem. So here's the problem. They want us to find where this line over here and this plane over here, where do they intersect? So let me just 3x minus 9y plus 2z. Three x minus 9y is equal to like 7. 3x minus 9y plus 2z is equal to 7. Perfect. And r of t 1, 2, 1. Okay. R of t 1, 2, 1 plus t. What is v?
-2, 0, 1.
-2, 0, 1. So when we have these two equations, the simplest thing first to do is to just figure out what x of t is. So x of t in this situation is 1, and then minus 2t. That's x of t. Y of t is 2, and then whatever, like 0t. And then z of t is equal to 1 plus t. And now we take these and we plug it into this equation over here. So we get 3x, which is 1 minus 2t, minus 9y, which is 9 times 2, plus 2z, which is 1 plus t, is equal to 9. So 7, sorry. So we set this equal to 7. And now we solve for t over here. So we get over here 3 minus 6t minus 18 plus 2 plus 2t is equal to 7. Or in other words, okay, 1 second. So yeah, this over here gets us to -13. So -13, and then -6t plus 2t, so minus 4t is equal to 7. So that tells us that -4t is equal to 20, which gives us that t is equal to -5. Okay, so now that we know what t is, we can find what our x, our y, and our z are. So in order to do that, we can just plug it in. So our x of t, so x of -5, is going to be equal to 1 minus 2 times -5, which is going to be equal to 11. Our y of -5 is going to be equal to 2, and our z of -5 is going to be equal to 1 minus 5, so that's 4. So 11, 2, and 4. So that's where the line and the plane intersect. Okay, so yeah. Any questions about this? No, it's clear?
Yep.
Okay, so yeah, so just one last time, the strategy is to just write what x is, what y is, what z is. to plug it in to your plane, set it equal to the d, to then solve for t, plug that solution back into the t in your x, y, and z, and that's how you get the point where the plane and the line intersect. Okay, so now they say graph the plane negative 2x plus 3y plus z is equal to 6, and then find its traces in the coordinate plane. So what they're really saying is they want us to graph this, and then they want us to set y and z to 0, and to graph the just x component. So that's when if we look at so 1 second. So the plane that we're looking at is negative 2x. So negative 2, 3, 1, negative 2. Okay, so this is the plane that we're looking at, and they want us to look at the traces in the different planes. So one of the traces happen when, so here's x, y, and z, happens when y is 0 and z. Well, 1 second. Do they, sorry. Okay, no, so this would just be, it wouldn't be a trace, sorry. Well, yeah, again, I'm not 100% sure. But what you can do is you can set y, for example, to be 0. So that's when this thing is 0. So now you're looking at the xz plane. So you're looking at this plane over here, xz. And we can look at the line that's created. So that's what happens when y is 0. So it happens when negative 2x plus z is equal to 6. And we can say that that means that z is equal to 6 plus 2x. So then that would be something like this. A line that looks like that, which in over here would be a line that looks something like that, which means that the plane, well, we can try to find another line and see what the plane might look like. We can also try to find the line in the xy plane. So let's look at the, here's x and here's y. So that's the xy plane. And that happens when z is equal to 0. So that happens when z over here is equal to 0. So that means the negative 2x plus 3y is equal to 6. Or in other words, 3y is equal to 2x plus 6. Or y is equal to 2 over 3x plus 2. So that would be something like this, and maybe the slope is not as drastic and it's not as high, so it looks something like this maybe. So then that would be something like this. And at this point, we can finish by saying that the other line would look like that, something like that. And so the plane should look something like this. Yeah, any questions about that? Okay, so in summary, for a plane passing through a point P0 with a normal vector A, B, C, we have that the vector form of the plane looks like that, the scalar form looks like that, or like that, where you have A, B, and C, which comes from your normal vector, and then you have your D over here, and your D is equal to A of x0 plus B of y0 plus C of z0. And the type of questions that they would like you to be able to find is, well, when two lines intersect, but when a line and a plane intersect, when two planes are parallel, and questions like that. So are there any questions about this section? Okay, if there aren't any questions, then next time we will continue with quadratic surfaces, but we will stop here. So I have not put the videos from the last two lectures from this section on YouTube. I'm going to try to do that today. If you have any questions, I extended the due dates for some of the homework assignments, but please try to do them. If you need more time, definitely send me an email, and I'll try to extend them, but try to finish the homeworks. And if you have any questions about that, let me know. And okay, that's basically it. So anything okay, so have a nice day. Bye.